In this demo, we will talk about these various stacks of container storage analytics appliance, and I will show the hardware, the OS, the Kubernetes installation, Portworx, and Elasticsearch. So as we discussed, this appliance holistically gives a solution where we can have virtualized storage running on using Portworx on Kubernetes as container orchestrator, and we'll run some Elasticsearch APIs or analytics applications to play with some of the database solutions which we integrate with Portworx. So very quickly I will jump onto the demo and we'll talk about all these layers one by one. As we can see, there is hardware involved here, and this hardware consists of 4 nodes, one master node and 3 agent nodes, and these are the software stacks installed on top of it. So we'll start as part of demo. We'll start with one master and one agent node, which we have used to install Kubernetes, and it is all running on using Ubuntu operating system. So these are 2 nodes. The left hand side is the master node where we have installed Kubernetes. We used kube control APIs or command line to install Kubernetes, and it provides it provides a specification called kube spray, and it provides step-by-step method to install Kubernetes environment on Ubuntu operating system. And we are using Ubuntu 18.04 server environment, and to do that we dedicated the 4 nodes which we were talking about. One node is the master, and there are 3 agent nodes, and we created, so as part of creating the Kubernetes environment, it requires us to create an inventory YAML file, which which we have created here. This is the master node, and if we go into the host.yaml file, this is the initial input file we have created to get kube control application to run. So you can see there are 4 nodes here: node 1, 2, 3, and 4. These are their IP address and different other information about it. When we do installation, we had set some default passwords and all that. So as part of this YAML, we give all these information. We say that node 1 is the master node, and 2, 3, 4 are agent nodes, and so on. Once we create this and we execute the all the required APIs or all the scripts provided by kubespray, it creates a Kubernetes environment for us, and we can run this command to see what are those whether those nodes are installed correctly or not. It shows that okay, the node 1 has master role, and these are the versions, and there are 3 agent node as well. So we went through all these steps provided by kubespray to get Kubernetes up and running. We can as well check the status of every other container running or all the pods running in Kubernetes environment using some of these commands. So it shows these are all the containers or pods running in this environment, and once we get it up and running, on top of it we will be going to install Portworx, and on top of it again going to install Elastic. But as a first step, when we got Kubernetes up and running, it gave us this dashboard. So we created the Kubernetes environment, and there are various ways to log into it. I use these code, the token code, which we generated as part of installation, and if we using that, we can log into that environment, and as you can see in the dashboard, it shows all these information. It is a standard Kubernetes dashboard. We can see various nodes, so we can see there are 4 nodes here. We can go to individual nodes and see their configurations and how much memory, CPU, pod allocations, and all these details. So pretty much it shows that the Kubernetes environment is up and running, and it is consuming 4 compute nodes using the hardware integrated in the Hyperscalers lab. So very quickly, once we achieved that, the next stage or next module we had to get was to get once we are in Kubernetes, we have to get the Portworx installed on top of it. So Portworx Portworx provides the virtualized storage capability solution on top of Kubernetes, so we can utilize the storage disk available within on Kubernetes and create a CSI type of storage disk or virtualized disk, which can be tied together to different containers on Kubernetes. So in a way, a virtualized storage solution is provided by Portworx. So Portworx provides various stages and various steps to get it up and running on Kubernetes environment, although it can be done on different other environment as well, like OpenShift, PKS, even on the cloud like AWS or Azure, it can be done. So in our situation, we are using Kubernetes, so we followed all these steps to get Portworx up and running. And once we do that, we can it provides us, like, if these are the various pods running on Kubernetes, and we can see there are few Portworx related pods as well. So it requires a minimum set of Portworx pods. There are 5 of them which are required to get the whole suite of Portworx up and running. So when we run Portworx installation steps, it creates these pods and gives us a Portworx environment. So I will quickly jump into the dashboard which Portworx provides. It's called Portworx Lighthouse. This is the front page. So it shows one cluster. We have one Portworx cluster running on top of Kubernetes, and we can see, I will just close it. We can see there are 6 drives. So as we said, there are 3 agent nodes in the cluster, 1 master and 3 agents, and all those 3 agent nodes have 2 hard disks specifically dedicated for this purpose. So each hard disk is about 1.7 terabyte, and there are 6 of them. So altogether, it creates 1.7 multiplied by 6 terabyte of one cluster storage, and that can be used for as one big chunk of storage volume, which can be sort of dedicated for different container storage applications. So Portworx this dashboard, Lighthouse dashboard, gives all those information. For testing or to evaluate the capability of Portworx, it provides different APIs or mechanisms. We can create multiple clusters using this and various other things. So as part of this demo, I will show one cluster. So in this cluster, I have created a test volume of 20 gigabyte size. The objective of this demo for Portworx is to show that on this particular test volume, what is the performance, IOPS performance I get. So this is one of the agent nodes where I have mounted that particular volume on a drive. So I can show it here. See, here we can see that this particular volume directory is where I have mounted the test volume. So test volume is a volume I have created using Portworx of 20 gigabyte size, and I am mounting it on a volume directory so that I can execute some IOPS on top of this mounted volume to get some performance numbers, sort of showing what are the read-write performance being shown by this particular volume. So after mounting it, if I run dd command, and I have created a random data file of 1 gigabyte size, and I am trying to write that file using dd and sort of trying to see what performance it shows me. So when I run this command, I have to give the admin password. It gives me about 600 megabytes per second performance. I have seen this doing better based on how many container solutions or how many pods are running. But in a normal situation, this is pretty good performance. We can see it is 1.3 gigabyte at this instance. So for the hard disk, the type of SSDs we are using, it is 1.2. It is a SAS SSD with 1.2 gigabits per second channel, and with that using a virtualized storage giving 1.3 gigabyte per second performance for data read and write is pretty good performance, because there are various other virtualized storage solutions which doesn't go beyond 600 to 700 megabytes. Although this performance can still go better if we fine-tune the memory and compute capabilities associated with this particular container solution. So in a way, this test shows us that we can have a good performing test volume which can be attached to different containers for different use cases, and it can give as good a performance as 1 gigabyte per second as it shows. And this dashboard, the Lighthouse dashboard, updates itself periodically. So after some time, after a couple of minutes, since we have added one more 1 gigabyte data here, it will show 3 gigabyte in few minutes. So in a way, this dashboard gives the view of the utilization of storage and various containers running there. So we can see the containers as well. So for example, we are running some elastic environment. So as the next step, once we got Portworx up and running, we installed Elastic on top of it. So that Elastic sort of spawned these 5 containers, and it requires different volumes. So it is utilizing few of these volumes to create Elasticsearch specific environment. We'll show those volumes as well as part of demo. So now we can see that this 2 gigabyte used space has gone up to 3 gigabyte because we ran an IOP test, and it wrote 1 gigabyte extra data, and we were hitting a performance number of 1.3 gigabyte per second, which is pretty good for a virtualized storage solution on containers. Portworx also gives Grafana and Prometheus dashboards. So using this, we can create different data snippets, different databases. We can create graphs, and using Grafana, we can create the dashboard for that. So Portworx is very feature-rich solution, cloud native platform, and it provides a platform to create all those environments. Okay, so that is as far as Portworx goes. Very quickly, I will jump to next phase where we talk about Elastic on top of Portworx. So as we saw in our architecture, we have Ubuntu as OS, we have Kubernetes as container orchestration, we had Portworx as cloud native platform to build applications on top of itself. So we got till Portworx, using which we are able to create virtualized storage, different storage volumes. Now we will see how to get Elasticsearch work on top of it, and using Elastic, how can we push some database on the storage of Portworx, and how we can run the analytics using Elasticsearch. So Portworx provides those steps. It can create Cassandra, Kafka, and Elasticsearch and Kibana using Kubernetes. So sorry, using Portworx, and we followed all these steps. It requires we were seeing some of the pods running on top of Kubernetes. So a few of them were specific to Portworx. So it requires 3 master nodes, 3 data nodes, and coordinator nodes. So we created YAML files to create an environment for Elasticsearch, and using kube control and various other Portworx instructions as described here. We got Elasticsearch up and running. We can see some of, if we dump the pods and grep for Elastic specific pods, we can see there are 3 master nodes, 3 data nodes, and 2 coordinator nodes, which are the containers running on Kubernetes, and it creates a Elasticsearch environment for on top of Portworx. And this Elasticsearch utilizes the volumes created by Portworx within itself, and it sort of distributes the storage across various agent nodes. So in a way, the combination of Kubernetes and Portworx is giving a platform to get Elasticsearch up and running. And once we install all of that, we got Kibana running as well. So this is the Kibana dashboard, which gives the Elasticsearch, which runs on top of Elasticsearch environment, and we can run analytics on the databases running on top of Elasticsearch. So, for example, I downloaded a YAML file, rather a JSON file, which is a database consisting of about 500 entries, and it has the information about the account number, the balance, first name, last name. So about a customer, I mean, one entry consists for a particular customer, and this is a database which we have uploaded on Elasticsearch. So there are various steps to upload the database. We followed those steps. We can sort of download the JSON file, and there are steps to upload it. It is all detailed here. We can push the JSON file using the commands. I will quickly show that command. Yes. So this is the JSON file we are using, although we can create different other JSON files as well. This is the step by which we are putting the JSON file in Elasticsearch, and after doing this, the file shows up here. If we go to the management, and if we go to index patterns, so we can see there are 2 databases. One is customer, one is bank. So these are the indexes field for customer, and we can, if we go to DevTools and we just run the indices, it will give us the dump of all the database populated on Elasticsearch. For example, we have bank, we have customer, and various others. So what this shows that we are able to push huge databases using Elasticsearch APIs, and we are able to visualize them on Kibana. Now to dig a little deeper here, what I have done is, if I go to visualize, and we can create different search parameters. For example, I am searching for terms and with specific keyword, which is a city keyword. So what it does is, if I run this, it will find, it will go through all those 500 entries of databases, and it will find first 20 city names, and it will display it in this format. So I can change it as well. Like if I give 30 here, it will find first 30 city names, and it will refresh it. So we can see here there is Bayview and base and all these city names. So in a way, we can play with this. We can change. We can search it for keyboard names. We can search for first name, gender, and all that. So we can, for example, if I do first name metric count first 30 and execute it, so it is giving me the top 30 entries of various names. So these are the names of customers: Andrea, Anastasia, Amber. So we can manipulate all this. We can set different names here, different filters here, and it will give the data. We can arrange that. So uh, as well as we can see the data entries here, we can see the size, the storage size it utilizes, and we can do some monitoring as well. Yes, we can see this, how much storage is available, and various other things. So we can explore it further. So, but the objective of this demo of showing that we can this particular architecture creates an appliance to which we can run container storage and analytics solution is verified. As far as the customer use case go, the objective is to this appliance would sit on the edge environment of a cloud platform or a data center, and it has to gather the network information at runtime, use the virtualized storage capability of Portworx to create volumes to maintain that data, and then run the analytics on that data to see the network performance or various other factors recorded as part of that network captures. So we have this appliance up and running in Hyperscalers lab. We are happy to give access to anyone who wants to play with it. This table gives the hardware and some of the software details of the whole appliance, and we demoed the solution. We are able to gather some of the benchmark numbers for this solution as well. So yes, so that's as far as this solution goes, and thank you.